All right, today's lesson is quite a bit different than what we did the last two lessons. All right, seems like they don't have anything to do with each other, and they kind of don't. um, but this is called inequality. So the first two lessons are very, very similar to each other. This one is quite a bit different. So let's do this. Let's make this so I can write on here. Always forget to do that. We'll do that. We'll do that. Okay, so we should be good to go. Let's make sure I can write. All right, that looks like it's good. All right, we're gonna do this one thing. Let me move this thing out of the way first. All right. All right, write this down. This is a property, and this comes into play for this lesson. Shh, girls, enough. Thank you. It's called the comparison. That's supposed to be an I, just not much separation between there. That's a comparison property. Now this looks like it's basically common sense, and it is, but we're going to take this and we're going to apply it to some geometry stuff, okay, with triangles and all that, like we normally do. All right, so here's what it says. It says if A is equal to B plus C, then, I'm sorry, yeah, that's good enough. Then A is greater than B. Remember your greater than equal symbols? Have we done those this year? Have we done greater than or equal yet?
Yeah, we know. It's just
yeah, I know you know, but I'm saying this year. I'm asking you this year. Have we done it in this class?
not yet.
Okay, that's all I'm asking. All right, so, shh, stop. So this means greater than. When you're a little kid, they taught you like the alligator eats the bigger number or something like that. And that's okay when you're a little kid. But let me just show you a quick little history. I think it's the history. I don't know. I never looked it up, but I'm pretty sure this is it. What's an equal sign look like? Looks like that, correct? Right? Look at the space between these two and these two right here. Okay, they're the same, right? They're equal to each other. So this is an equal sign. All right? If I go like this, now, look at the space between here and here compared to the space right here. What is this? It's bigger, isn't it? It's greater than, all right? And if I go like that, look at this space right here on the left. That's less than the space between here and here. You see that? So that's less than. So this is equal, this is greater than, this is less than. Now, I can read, let's put like 5 is greater than 3. Do you agree with that? Okay, yeah, 5 is bigger than 3, right? We could also write it another way. We could actually write it from right to left. Anaya, let's up here, okay? We're not doing that here. So if I read it from left to right, I would say 5 is greater than 3. What if I read it from right to left, though? What would this be? This would be 3 is what? Less than 5. 3 is less than 5. Are these inequalities? They say basically the same thing, don't they? Yeah. Okay, but we normally read it from left to right. There will be some times, I don't know if in this lesson really, but there will be some times, especially maybe in algebra, where you're going to look at some things and you're going to read it from right to left. All right, so, but they mean the same thing. So that's that. Let's go back to this then. That was just an inequality. So but basically, those are called inequalities. The equal sign is an equality. The greater than is an inequality because they're not equal to each other. The less than is also an inequality because they're not equal to each other, all right? Everybody with me on that? What if I wanted to make an equality? I would say 5 is what? Equal to what? 5, right. Okay, you couldn't put a 3 there and put an equals in. Agreed? All right, so you got an equality, you got inequalities. We are going to be dealing in this lesson with several inequalities. And in the next lesson, too, we're going to do some more with some inequalities. And there's a whole entire chapter? Maybe not a whole chapter, but there'll be other times we're going to do some more inequalities. Let's see what this means right here. Let's see, why in the world would they say this? It says if A is equal to B plus C. Now, we have to also take in consideration C must be a positive number, okay? So we're not dealing with negative numbers. We're just dealing with positive numbers. Everybody okay with that? All right, so C has got to be a positive number. So if you look at this, if A is equal to B plus C, that means B plus C have to add up to be A. So what's my biggest number out of A, B, and C? A's got to be the biggest number. Would you agree? Because if these two things add up to be this, right, then A has got to be bigger than either one of these, right? I could have said then A is greater than B, and I could also have said what? A must be greater than C. Right, I could use either one of those, couldn't I? Does that make sense? Let's put some numbers in there, and let's see if it makes a little more sense. It probably does already. Like I said, this is kind of common sense, to tell you the truth, but we're going somewhere with this, I promise. So what if I said like 7 was equal to 3 plus 4? Let's see if this actually works. All right. This says A must be greater than B. So is 7 greater than 3? Yeah, it works. Okay, also, A must be what? 7 must be greater than what else? 4. Okay, in this situation. So is 7 bigger than 4? Of course it is. All right. Is there any situation, as long as C is greater than 0, and that if I add these up, or I should say this, that this A is going to be smaller or equal to B and C? No, it's not. All right. It's always going to be bigger. Everybody with me on that? Yeah, that's not that big of a deal. Let's move on and see why in the world are we talking about this. Okay, there is a reason why we're talking about this, and it does have to do with geometry. So let's scooch this up out of the way, and let's write another thing down. This is a theorem. It's a kind of lengthy name of a theorem, but we'll write it down anyway. It's called the exterior angle. We've actually done a little bit with exterior angles. Do you remember that? Remember we had a triangle and we extended one of the sides. We had an exterior angle. And then we had 2 remote interior angles. Is this ringing a bell? All right, so the exterior angle is equal to the sum of the remote interior angles. So we're going to go back to that. All right, so hopefully you didn't forget all that. So the exterior angle, this time though, we're going to talk about inequalities. We're not going to talk about necessarily what's equal to each other. We're going to talk about what's not equal to each other. All right, so if I had, let's draw that triangle where we extend one of the sides right there, and let's say right there. You remember that situation, don't you? Yeah. And we'll call it ABC, this way right there. I'm just going by what's in my notes. And let's call this angle 1 just to make it a little easier, and that just keeps going, okay? Now, what this theorem says, this theorem basically restates the comparison property that we just finished doing with the numbers, okay? But in this case, we're dealing with angles, all right? Which in turn are numbers, aren't they? Don't we measure an angle with numbers? Yeah, we measure it in degrees, okay? So it's basically the same thing. So what this is saying, now remember from the exterior angle theorem, not inequality, but the regular old exterior angle theorem, what did we say? What was the relationship between these angles right here? We said angle 1 was equal to what? I just said it a minute ago. Angle what? ABC? Remember we said the exterior angle is equal to the sum of the remote interior angles? Which ones are the remote interior angles here? B and C. So angle 1 must equal what? Angle B, not and C, what? Plus angle C. All right? Don't say and, say plus. All right, because when you say angle 1 is B and C, it just doesn't always work. So anyway, angle B plus angle C. Agreed? Now, using that comparison theorem, what then could you say about angle 1 to angle B? You must say that angle 1 is what? Greater than angle B. And you must also be able to say that angle 1 is what? Greater than angle C. All right, that's pretty important sometimes. All right, without even knowing what the measurements of these angles are, all right, I have no idea how many degrees they are, but I do know that angle 1 has to be bigger than angle B. Does it look like it? Sure, because this is obtuse, right? This is acute, so any obtuse angle has got to be bigger than an acute angle, yes? All right. Now, you can't always go just by what it looks like, but I'm just trying to get you to see that, yeah, definitely angle 1 is bigger than angle B, and angle 1 is even bigger than angle C, all right? So we know that that's true, all right? So that's kind of important too. All this leads us up to what we're going to do right now, and then we'll stop with this next little thing that we're going to do. There's a little bit more to the lesson, but we'll finish that tomorrow just because of time. All right. One more theorem. They call this the greater angle theorem. The word greater is also indicating an inequality, isn't it? All right, if something is bigger, greater than something else, that must mean they're not what? Equal to each other. That's right. So that's an inequality. If they're not equal, then it's unequal, however you want to say it, right? It's called the greater angle theorem. I tell you what, instead of just writing out the whole entire theorem, I am going to just draw a picture for you, and maybe that will make more sense. A lot of times in geometry, the picture makes way better sense than just reading it all off, because it just becomes a jumbled mess when you start reading a whole bunch of words. There we go. Let's call it ABC again. So A, B, C. Yeah, let's do this. Make that 100 degrees, make this 60 degrees, and make this 20 degrees. All right, so I've been told this. Okay, this is what I was told about this triangle. All right, so I know all that stuff's true. I didn't just make it. Well, I kind of did make it up, but you get the idea, okay? That those are the angles. What we're going to be able to do, and this is going to be like a quiz question or a test question, okay? I'm going to ask you to tell me what sides are the biggest side, what's the smallest side, and what side's in the middle, all right? Now, you could just look at it and just kind of guess which side is the biggest side, but you can't always do that because it's not always going to be drawn to scale. There'll be situations where this says 60, but it may not really be 60. This says 100, but it may not really be 100, okay, and so forth. What I want you to do is be able to tell which one's the smallest side, the middle side, and the biggest side, not by looking at the triangle and just guessing, because, that side's definitely the shortest side. I mean, if you look at this one, what side is definitely the shortest side?
The right one.
AB, that's what I want. AB, the right one. I mean, you can't just say the right one. Let's be specific. We took a lot of time at the beginning of the year to talk about lengths of sides and, naming them and all that kind of stuff. It definitely looks like AB is the smallest one, okay? But our theorem says this. I'm going to read it off to you. I'm not going to write it down just because of time. But it says, if two sides of a triangle are not actually, I kind of, I wrote the wrong one down first, but let's see. Actually, this is not the greater angle theorem. I wrote the wrong one down. I don't know why. I should have corrected that in the notes. Maybe I thought I would remember. This one, the next one we do is the greater angle theorem. This one's called the longer side theorem. Okay, so we'll do that one later. This one is the longer side theorem. I was wondering why what I was reading didn't make sense, but now here's what it says. If two angles of a triangle are not congruent, do we have two non-equal angles here? Sure, we got all three angles that are not equal. So if we have that situation, it says the longer side is opposite the larger angle. Did you hear what I just said? The larger side is opposite the larger angle. So what I'm going to ask you to do in the homework, in a quiz, on a test, I'm going to ask you to list the sides, the lengths of the sides, in order from smallest to the largest. Okay? So you're going to list the sides from the small one to the large one. So our theorem says this. It says that the longer side is opposite the bigger angle. You could also say that the shortest side is opposite the what? The smallest angle, right? The shortest angle, the smallest angle, okay? We don't usually use short for angles, but the smallest angle. So which one is the smallest angle? 20 degrees, right? So look at the side that's opposite to 20 degrees. Which one is it? AB. So that's got to be the what? The smallest side. All right, so AB is the smallest side. Let's put it in order from the smallest to the biggest. So which one's the medium one? Well, take a look at the angles. Which one is the medium angle? The one that's between the smaller and the bigger one? The 60 degrees. The 60 degrees. I said what angle, and you're telling me AC. That doesn't make any sense. If I say an angle, all right, you got to use either 3 letters or 1 letter or give me the number, right? AC is not the middle-sized angle, all right? So I'm just trying to point out, what your mistake was. Anyway, here we go. So 60 degrees is the middle-sized one, correct? What side is opposite the 60 degree? BC. See, that's opposite. Everybody see it? So what's next in line? BC, all right? And then, what do you think is the biggest angle? Now you can say what you're going to say, Timmy. What's the biggest side?
AC.
AC, because it's opposite the what? It's opposite the biggest angle. All right, this is the biggest side because it's opposite the biggest angle. So you know for a shadow of a doubt that that's the order of the sides. AB is the smallest, BC is the one that's in the middle, AC is the one that's the biggest. We just took a test in my other class, in my honors class, and this kid got a lot of these wrong because he didn't read the instructions. All right, he put them in order from the largest to the smallest. Now I could ask that on a quiz or a test, right? But you have to read it and be able to see. What if I did say from large to small? Then how would you write it? AC, BC, and AB. That's right. So you got to make sure you read the instructions and know what they're asking for. Let's do another one super quick. This one is the greater angle theorem.
I'm sorry.
You're sorry? Why are you sorry?
Huh?
Why are you sorry?
Because I'm just sorry.
Why'd you call me dude? Didn't we have a talk about that before?
Oh, yeah, I'm sorry for that too. I'm sorry. Never happened again. I'm sorry.
Yeah, I bet you it will.
No, sorry.
Okay.
No bets. No bets. I don't do that. I don't do that gambling stuff.
Okay.
What?
All right. What do you think the greater angle theorem says? This time I give you the sides, right? What do you think they're going to ask you to put in order? The angles. That's right. Okay. So just take a wild guess. I mean, it's very similar to the one we just did. So what are we going to look for? Let's go from smallest to largest. Okay. Let's go from small to large. What's the smallest angle? Now, again, it's kind of hard because look, all these angles almost look the same, don't they? So it's really difficult to tell which one's the smallest one. How do you know it's L? That's right. The smallest side, right. Smallest side is 12, angle L. So angle L. Put the angle symbol there. Don't just put an L. Put angle L. And what's the middle one then?
13.
Well, that's the side, but what's the angle? This is the middle one. Angle N. All right. And then the largest side is 14, but what's opposite? What angle is opposite 14? Angle M. And that's all you have to do. It's pretty simple, isn't it? If you know what the theorems mean and say. All right. So we will finish this up tomorrow, and there's no homework tonight. If you want to start on it, you can.
We could do the quiz tomorrow.
It's up to you.